Welcome to Site Assessment and System Sizing module. A solar power plant, whether a 2 kilowatts rooftop or a 50 megawatts utility scale system, must be designed to match the customer's energy needs and the site conditions available. The success of any solar project begins with one critical step: a precise and comprehensive site assessment. In this module, we will explore the process of surveying a site, analyzing constraints, performing shadow and layout studies, selecting suitable locations for different types of PV systems, using essential tools, evaluating electricity bills, and carrying out preliminary system sizing. By the end of this video, you will understand how accurate site assessments directly impact energy yield, financial returns, and long-term system reliability. A solar PV plant's economic success depends heavily on how well the site is evaluated. Site assessment evaluates physical features, electrical infrastructure, commercial and financial viability. Accurate surveys ensure efficient solar irradiation capture, proper module layout, correct azimuth and tilt, accurate shadow estimation, reliable financial modeling, compliance with safety and standards. A thorough assessment allows installers to identify optimal locations for solar panels, maximizing energy captured and improving system performance. A site survey begins with an initial site visit to gather physical, electrical, and commercial information. Key elements include measuring available rooftop or land area, identifying shadow-causing objects, understanding terrain contours for MW scale projects, assessing grid infrastructure and voltage levels, checking access roads and nearby substations, reviewing historical energy consumption, collecting data on load patterns and future expansions. For large ground-mounted projects, the survey includes soil type, presence of rocks, water drainage patterns, land ownership and boundaries, feasibility of evacuation lines. For rooftops, constraints include parapet walls, tanks and heating, ventilation and air conditioning, HVAC units, existing electrical infrastructure, structural integrity. Calculations using sun path diagrams help determine inter-row spacing for optimal irradiation. Site analysis converts collected data into a design-intelligent layout. Key analytical tasks include orientation and tilt. Determine correct orientation, usually south-facing in the northern hemisphere. Tilt selection affects seasonal production. Inter-row spacing calculation. Using sun path diagrams, spacing is optimized to avoid morning and afternoon shading. Capacity determination. Balancing customer energy needs, site area, applicable regulations, budget constraints. Ground coverage ratio, GCR optimization GCR, is the ratio of panel area to total land area. Higher GCR increases capacity, but may reduce generation due to shading. Analysis identifies the optimal GCR to maximize performance. Shading can drastically reduce PV output. Shadow analysis identifies both external and internal obstructions. For rooftops, common shadow sources include tanks, parapets, trees, neighboring buildings, antennas, poles, and ducts. For ground-mounted plants, shading comes from building structures, substations, poles, boundary walls, light poles, lightning arresters. When shadow is unavoidable, group shaded modules in one string. Use landscape orientation to minimize impact. Simulation software provides seasonal shadow patterns to guide layout. Site selection varies significantly based on the type of PV system. Grid-connected rooftop. Assess shadow-free area. Consumption details. Historical plus future. Voltage levels. Distance to interconnection point. MW scale ground-mounted systems. Evaluate terrain and contours, land boundaries and ownership, water bodies and drainage channels, access roads, substation proximity and capacity, right-of-way for transmission lines, solar mini-grids, information required, locations of components, consumer distribution, load profiles, AC-DC, voltage, operating hours, cable routing and right-of-way, seasonal consumption variation. Tools help ensure accurate, reliable, and standardized surveys. Physical tools, measuring tape, laser rangefinder, compass, drone for mapping large sites, clinometer or tilt meter, digital tools, sun path diagram mobile apps, solar irradiation calculators, shadow analysis software, satellite maps and GIS tools, electricity bill assessment, electricity bills reveal, historical consumption, peak usage months, tariffs and slab rates, maximum demand charges. For off-grid surveys, load wattage decides inverter size, daily energy determines PV and battery sizing. Once survey data is complete, preliminary system sizing begins. PV module DC capacity based on daily energy requirement, kilowatt hour, available area, budget and regulatory caps. Inverter AC capacity for on-grid based on DC capacity of modules. For off-grid based on maximum load wattage, battery capacity, off-grid. Depends on daily backup hours, load demand, depth of discharge, days of autonomy. Final sizing and technology selection are done during detailed engineering. The International Electrotechnical Commission, IEC standards, ensure PV installations are safe, reliable, and consistent with global best practices. Key standards relevant to site assessment include IEC 62446, Documentation and Commissioning Requirements, IEC 61724, Performance Monitoring, IEC 61836, IV Measurements, IEC 61853, Module Performance Testing, IEC 61730, Module Safety Qualification. These standards guide installers on expected output, data collection, safety requirements, and module quality. Accurate site assessment and correct system sizing form the backbone of a successful solar PV project. By gathering precise data, understanding shading and layout constraints, and applying sizing principles and standards, installers can design efficient, cost-effective, and high-performance solar systems. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.